going to be talking about transformations, and this is going to be the very last new lesson for our unit on graphing linear functions. And so first, for just some vocabulary, we call a family of functions is a set of functions whose graph has basic characteristics in common. And for our purposes, we're going to be looking at the family function of linear functions. But later on in the year, we'll learn about quadratic functions, we'll learn about exponential, and so we'll look at those family functions as well. A parent function is the most basic function in the family. It's the simplest one. And a transformation of this parent function is a change in position or size of a figure. And so we kind of see that right here. Here I have f of x is equal to x, that's my parent function, but I can see it changes where it is at based on what you add to it or multiply to that parent function. And so the linear parent function is the most basic function family again, and for us that's going to be f of x is equal to x. Or in other words, you can think of that as y is equal to x. Because remember, f of x and y are the same thing. And so if you're thinking about that in slope-intercept form like we learned before, that means that my parent function is basically when my slope is just 1 because I don't have any number in front of x. And since I don't have anything added to this, that means that my y-intercept is 0. So my most basic function for linear functions is going to be y equals x, when my slope is just 1 and my y-intercept is at 0. So before we get into this transformation summary, I want to show you guys some transformations that we can see in Desmos. So here I have my parent function y equals x. And I see if I go ahead and add, let's say, 2 at the end of it, I see from my red parent function, it went up 2. Okay, now let's subtract 2. And I see that it went down 2. Okay, now let's see how the slope affects it. So if I make my slope, for instance, 3, I see that it got stretched there, it got skinnier, it became a little more steeper when I had a larger number. Or if I have 5, it gets even steeper from there. Okay, now let's try a fraction there. So let's say I had 1/2. Well, now that I see it's getting compressed, it's getting less steep. It's getting closer and closer to the x-axis. Okay, let's make that 1/7. Now I see it went even lower. It is getting closer and closer to the x-axis. So when my slope is a fraction, it's between 0 and 1, it gets closer to the x-axis. Where if it's greater than 1, I see it's getting closer and closer to that y-axis. Okay, now let's say my slope is negative. Well, now I see when I put a negative out in front, it reflected, it changed directions completely, and now it's going downhill instead of uphill. And so if I have like negative 3x, I see that same thing. And so we can actually go ahead and see what transformations are going to happen based on the equation that we have for that line. And so kind of a summary of that. A plus or minus out in front of our slope. The plus, that means nothing. It's just going to stay. The minus, that means it's going to be reflected across the y-axis. And so we saw that in our graph over there in Desmos. My parent function was going this way, but as soon as I made it negative, it reflected across the x-axis and it went the opposite direction. Okay, and then the m, that can do a few things. If m is greater than 1, we saw it got steeper and kind of got higher up. What we call that is stretched. If m is equal to 1, well, that's the slope of our parent function, so nothing happens, stay the same. And then if m is less than 1, or really if m is between 0 and 1, we see that it was compressed. And so that's when you see those fractions. So for instance, if I had 1/2, 3/4, here you need to be careful. It's a fraction between 0 and 1. However, if you have, for instance, 3/2, 3/2 is greater than 1, so that wouldn't mean it's compressed. So it's only when it's less than 1, a fraction less than 1. Okay, and then our plus b, when it's a plus b, moves graph up. Minus b moves down. Okay, that's it for this video. Go on to the next one where we will be looking at graphing these transformations.